It's my pleasure to introduce Edwin Greyling, who's going to talk to us this afternoon about data management. Edwin has a fairly recent honors degree in environmental water management from Rhodes University. He works for Groundwater Consulting Services as an environmental hydrogeologist. And that's about all I can say at the moment. With that, Edwin, please take it away and let's teach us about data management.
All right. Good day all. I'm glad you could all join us on this public holiday. As previously mentioned, my name is Edwin Greyling and I'm currently working as a consultant for GCS. I hope everyone's been keeping safe recently with regard to the COVID-19 outbreak and so on. I mean, we've just breached a new horizon, which is stage 4 as of this morning. So I'm really hoping that from here it only gets better and that one day we will all be allowed outside for more than 3-4 hours a day. But yeah, with no further ado, I'm going to be hosting a webinar today on eSymon. eSymon is essentially an acronym which stands for Electronic Data Management System for Monitoring. eSymon was developed by Yuri Berenek, who's a software developer who works as a consultant in our GCS Czech Republic office. My colleague within the water monitoring unit at GCS, her name is Tarika Isaac. She is responsible for product management in South Africa. Okay, so with no further ado, let's get started then. As we all know, there are multiple challenges which arise with regard to data management. Monitoring of the environment usually generates a significant amount of data, and if this data is not systematically stored, many problems will arise. Some of these problems could be limited access to historical data due to poor storage of data in different formats, as well as the continuity of the data and the integrity of the data. With all of this being said, it can essentially be noted that years of historical data cannot always be used or trusted. We at GCS therefore developed eSymon and see this as somewhat of the solution to the problem. What eSymon does is it systematically stores large volumes of monitoring data, as well as provides remote and instantaneous access to real-time data. eSymon allows for data visualization using a GIS interface, as well as creates various outputs such as time series graphs, geochemical diagrams, and contour maps. There are a couple of unique features of eSymon. Let's discuss. eSymon is essentially an open source solution. Third-party map and graph components are used, and the remaining components have been developed by GCS. Therefore, the software can be used without having to buy separate licenses for each eSymon user. eSymon also has the ability to be customized to meet each user's specific requirements. The developer, Yuri, that I mentioned earlier, is in-house and can therefore incorporate a user's thoughts, suggestions, and improvements into the software. I'm now going to show you a short video demonstration of the GIS interface within eSymon. For this example, we'll be looking at our area of interest, which is namely Mine A. Within Mine A, there are a number of different monitoring surface layers. These are surface water stream related, surface water process related, as well as groundwater. Each layer can, for example, be looked at individually or as a conglomerate of all three. With regard to the background map, many background map options are available in eSymon, ranging from various Google Maps and terrain maps. Here, the first tool within the GIS interface that I'll show you is the selection tool. Here within the yellow square, we have selected a number of monitoring points. The next tool that I'm showing you within the GIS interface is simply the pan option. Here you are panning up, down, and around. The next tool that I'll be demonstrating is simply the zoom in function, followed by the zoom out function. Lastly, within the GIS interface, here is the distance measuring tool. Here measuring the distance from monitoring point MMB 19 to MMB 15. This example, measuring the distance from MMB 30 to MMB 16 and then to MMB 29. All right, so that was a short video demonstration of the GIS interface within eSymon. Moving on to eSymon's functionality. There are currently 3 main categories of monitoring data that can be input into eSymon. Firstly, geotechnical monitoring. Secondly, water monitoring. And thirdly, general monitoring. With regard to geotechnical monitoring, the following types of data can be input into eSymon. This is geological documentation, convergence data, extensometer data, dynamometer data, inclinometry, and seismic monitoring, which is currently in progress. With regard to water monitoring, surface water flow data can be incorporated into eSymon, water level data can be incorporated, as well as geochemistry data. With regard to general monitoring, the following types of data can also be input into eSymon. This is weather monitoring, including measurements of soil moisture content in a soil profile. But what must be noted is that eSymon's potential is essentially unlimited. For example, if a client were to have a whole bunch of different water monitoring components, such as surface water flow data as well as geochemistry, however, the same site incorporates dust monitoring as well as SAS assessments, eSymon will be customized to that client's needs, where all different components will be incorporated into one tool that can be used for the specific client. Moving on, here's another short video demonstration. This video demonstration is how to create time series graphs within eSymon for a single parameter. Okay. If you look at the left-hand tab under parameters, you can see all the different geochemistry parameters within the program. This is for a specific site. However, for this example, we have decided to look at sulfate. Once you have selected your relevant parameter, in this case, you need to select your relevant time period, from when to when you would like to look at the data. This could be for the entire monitoring period or for a specified period. Once you click on top left in the Create tab, the data will be represented in a table format on top, as well as in a graph format at the bottom. Here, what is important to notice is that the graph can be exported as an image and therefore incorporated into technical reports. The next short video demonstration that I'm going to be showing you is creating time series graphs, but this time with multiple parameters. For this example, we've decided to look at the relationship between sulfate and total dissolved solids. Once both parameters have been chosen, once again, select your relevant time period from when to when you would like to look at the data. This is always followed by the Create Graphs tab. Once that's been clicked, your data will once again be represented in a table format on top with your graph format at the bottom. As previously mentioned, this graph can be exported as an image and incorporated into technical reports. When clicking on Time Series 2, one gets options to create multiple graphs with multiple chart types and multiple parameters. For this example, let's choose electrical conductivity as a line chart, choose sulfate as a fold line chart, and then choose chlorine as a bar chart. Once again, make sure to select your relevant time period from when to when you would like to have a look at the data, easily followed by the Create Graphs tab. Your output will then be your 3 relevant parameters in the relevant chart type that you have selected for each parameter. Any deductions can be further made from this point on, or any correlation between the different parameters can easily be seen. The next short video demonstration that I'm going to be showing is with regard to geochemical diagrams. If one were to click on the Geochemistry tab within eSymon, a range of different geochemistry diagram options arise, ranging from sieve to Piper, Duroff, and Scholler diagrams. First of all, the most important part is to select your relevant time period and your relevant monitoring point, followed by your aggregate function, and then create diagram. In this example, we've created sieve diagrams for our relevant monitoring points for the relevant chosen time period. Next, let's create some Piper diagrams. To create the Piper diagram, similarly as to the sieve diagrams, what will need to occur is you need to select your relative monitoring point and relevant time period, followed by your aggregate function, and then clicking on Create Diagram. Your output will be your Piper diagram with different subheadings and an editable key. Next, let's create a door-off diagram. For the door-off diagram, no different to the stiff diagram or Piper diagram. Once again, your relative monitoring point as well as monitoring period needs to be selected. This again followed by your aggregate function and then create diagram. Your output, once again, is your door-off diagram with relevant subheadings and your key. Lastly, I'll be creating a shoulder diagram. For the shoulder diagram, no different to any of the other geochemical diagrams, the relevant time period and monitoring points need to be selected. Once your relevant time period and monitoring points has been selected, you choose your aggregate function, followed by create diagram. What is important to note here, with regard to all geochemical diagrams, as previously mentioned in other video demonstrations, these diagrams can be exported in an image format and therefore incorporated into technical reports. Here's a screenshot of a geological documentation output that gets created within eSymon. eSymon provides visual representation of map data on StereoNet type diagrams. The software can also graph geotechnical inclinometry data, as shown in the screen grab below. The following is a screen grab of a contour map created within eSymon. These contour maps can easily be used to determine problem areas within a selected area with regard to chemical concentration. Moving on to eSymon's functional model. Essentially, what needs to be noted here is that eSymon would be to provide, a client would be to provide GCS with past data for your selected area. GCS staff will then meticulously clean and create a formalized database which is compatible with eSymon with that data. An account with two sets, an account with two sets of personalized login details gets provided to the client. The client is then also provided with a training session by GCS staff to make sure that the software is used to its full functionality. Essentially, what the client can then do is create outputs such as what I just demonstrated in the previous video demonstrations and screen grab images. The data then also gets updated monthly or quarterly, depending on the project scope by GCS staff, to allow for the client to look at real-time data. With regard to access and security, we must all please note that the connection between the user application and the MySQL database is secured and encrypted by a tunnel created through an SSH protocol. Each user is provided with two sets of login details for the connection to these components. The user is also able to send an error message directly from eSymon to Yuri, our developer, if need be. So essentially, there are a couple of key benefits of eSymon. eSymon will save a lot of time. eSymon also provides accurate and up-to-date information. One of the main benefits is that one does not have to wait for technical reports to make sure that one is adhering to legal limits or even assess trends. eSymon provides several means of data visualization and creates automated outputs, including connection to databases of other entities. eSymon also has a very simple user interface for clients, as what I demonstrated through these short videos. There are a couple more unique benefits to eSymon, these namely being that we have an in-house developer that can add features to the software to cater for each user's specific requirements. eSymon is essentially an open source solution and can therefore be used without having to buy separate licenses for each eSymon user. As previously mentioned and elaborated throughout the presentation, eSymon's potential is unlimited and can be formatted to reach out to each client's specific needs. I want to thank you for listening to my webinar that I've hosted today. On screen now, you can find mine as well as Tarika's email addresses for any personal questions or if you have any in-depth questions that you would like to ask with regard to eSymon. Other than that, the floor will be opening now to general questions if anyone has a quick question or two. Before the floor does open, I just want to let you know that my unit manager, Kelly Pickering, will also be online now to assist with questions. Once again, I thank you guys very much for your time and listening to my webinar. Stay safe, everyone. Craig, I think we can now open the floor. Yes.
Yep. Thank you very much. If you can raise your hand and unmute your mic, Any questions or comments? I don't see any. Edwin, just the development of this product, was this largely a South African effort or an international effort?
Well, look, the Yuri that I mentioned in the beginning of the presentation, he developed, he mainly developed it. He is from the Czech Republic, but he works very closely with Andrew, who is essentially the founder of GCS here in South Africa. So I would say there was a bit of communication and collaboration between the Czech Republic and South Africa, but other than that, the product is somewhat mostly unique to us.
Any other questions or comments? Well, I don't see any more. Safiso, do you have anything you'd like to say?
Nothing from my end, but yeah, thanks to Edwin in demonstrating the capability of the software. Thank you very much for that.
All right, not a problem. Much appreciated.
Okay, with that, if there are no more comments or queries, I'll close the session. And see you back in the saddle on Monday. I think we have another presentation on Monday.
All right, perfect.
Julian Verne.
Once again, thanks for having me, huh?
Okay, no, you're certainly welcome. Thank you very much.
Okay.
Cheers
Stay safe,
all.
everyone.
I'll close
Cheers.
the meeting now.
Cheers.
Thank you. Cheers.